Welcome to Tech Talk with Trevor Galbraith, a video podcast that features industry leaders and experts from the electronics manufacturing community. Recorded at major events around the world and from the studios of Global SMT TV. Now here is your host, Trevor Galbraith.
Hello and welcome to Tech Talk here at SMTAI International in Minneapolis. Delighted to be joined by Stephen Eggart from a company called SMTAI Manufacturing. Nice to see you, Stephen.
Good to be here, thanks.
Yeah. So since the last time we spoke, you've had a few changes over at SMTAI and added some new technologies. So give us a quick catch-up on what's happened.
Yeah, sure, no problem. It's been pretty exciting. One of the first things that we added is conformal coating. Okay. We ordered an automated conformal coater from PVA. We're looking to increase what we do in conformal coating, and we think that this machine will help us do that.
Absolutely. So was that a customer-driven request, or was that generally you're
well, it's both, really. We have a couple of requirements for it, so we're looking to take care of it in-house and instead of sending it out. And additionally, we're looking to bring in some more contract business with conformal coating.
Right. Okay, good. Well, that should be useful for going forward. You know, the elephant in the room at the moment with most contract manufacturers, of course, is we've just come through the supply chain crisis. We're coming out the other side of it. Things are getting a bit easier. But a lot of CEMs are sitting with a lot of extra stock. What's the situation with you?
I think just like everybody else, sitting on a lot more than we'd like.
Right.
You know, I think it's the unfortunate it's the byproduct of the supply chain crisis. It is getting better. Inventory is getting lower, not as low as we would like, but we have more to go.
Okay. Now, one of the other changes I believe that you've made in the factory recently is you've completely changed the layout of the factory. Why did you do that, and what did you do?
So we took a hard look at every square foot we've got and figured out what we can do with it to be more efficient. Okay, we wanted to make sure our people were being more efficient in what they were doing, and making sure that we utilized all the space right. So we relayed out most of the equipment and all of our benches and where all our staff is working and everything. And the primary goal was the SMT line. We wanted to be able to change out jobs quickly and efficiently. And in order to do that well, we needed to kind of dedicate an area just to setting up the jobs themselves.
Like a kitting area.
And making sure you go through it, program, and make sure all the programs are correct, because you got a lot of software to play around with here. So you really want to make sure you have all of that in place ahead of time. And our internal goal is a 15-minute or less changeover time. Okay. And we have started to meet those finally.
Good. So I'm guessing part of that has also been some retraining and changing with the operators and the management team. What sort of approach have you taken there?
So we promoted somebody from within to kind of lead the SMT setup area and the kitting area. And he's going through all of the programs. He's going through all of the kits. He's finding any issues before they even get to the line. So when we get over to the SMT line, it's more just of an operations perspective, not figuring anything out. So all of our staff has been retrained with where to go, where things need to be moved to, where they come off, where do they go on, type of thing. So it's been a lot more tightly regulated as to exactly what they need to do.
Right.
But it makes it work better for everybody.
Yeah. Absolutely. And have you seen an improvement in quality with these changes?
Yeah. Oh, sure. Yeah. Rework is down because the less that you handle something, the better it's always going to be.
Absolutely. Great. Well, it sounds like you're going in the right direction. I mean, things are busy. Where do you think the company's going to be going in the next 3 to 5 years?
Well, in the next 3 to 5 years, we hope to continue growth from our existing customers and some new customers that we hope to bring in. And we're probably going to start needing more space at some point.
Right.
All right. You can only be so efficient with for so long until you physically need more square footage. So we'll look at that in time too.
Right. Great. Excellent. Well, we'll look forward in keeping a close eye on you, Stephen. You're doing a great job there. And thank you for coming in and telling us today.
No problem. Thanks for having me.
Okay. today is Don Dennison. He's from a company called PIT Equipment Services, and I'm delighted to say the US Rep of the Year last year with the Global Technology Awards. So nice to see you, Don.
It was great seeing you again.
Yeah.
It's starting to be a habit here. I really appreciate the exposure. It's great.
Yeah, well, you're certainly rising in the ranks amongst the reps in the United States. So bring us up to date, Don, about what's happening there, and perhaps start out by just giving us a quick list of your main lines that you represent.
Yeah. So I've been doing this for a number of years, and my principles are basically around this printed circuit board assembly, especially surface mount nowadays. Hanwha is one of my biggest lines for pick and place, and I sell the ESC printers through Hanwha.
Now, ESC printers, probably a lot of people won't know who they are. That's a South Korean company.
That's correct. They make a magnificent printer. I've been able to place a number of them in accounts that we're used to using, DEC or MPM, and customers are quite satisfied with them.
Right.
They basically run very simply. They're very easy to program, and my customers are real happy to put them in line.
Right.
And we've been doing more and more in my territory with inline systems and complete lines. And ESC lends itself well to that. We hook up destackers to them and conveyors and SPI equipment, AOI equipment. The Hanwha equipment works really well, and once we get it through the oven and out of the oven into another stacker, it really gets people's hands off of the boards.
Right.
We had a lot of companies in my territory, smaller CMs that were running batch systems, and it's quite nice to be able to put in complete lines now, and it's like the light bulb goes off in their head, like, why didn't we do this years ago?
Right.
But they're feeling comfortable doing it now, and the people that are working on the lines are certainly satisfied with what they're doing and what they're getting out of the equipment.
That's great. And what inspection systems are you representing?
So I've represented Saki in the past. I've represented Yamaha in the past. So I know inspection systems really well. I can program them and get people on board with the whole inspection process at this point.
Right.
So I think what's coming on strong right now is SPI.
Yes.
The ESC printer is great. It's got built-in inspection, but if you can do a full inspection of the board with SPI, it's even better.
Even better.
It's 75% of your problems with circuit board assembly come from the printing. So
correct.
Yep.
Correct. So I believe one of the most recent additions to your line has been the thermal profiling systems from Kick.
Yeah.
And I mean they're a very well-known, top-of-the-range system.
Absolutely.
So tell us a little bit about what you expect to do with that.
So I'm looking forward to working with Kick going forward. The system really supplies a lot of data to the customers. Most of my customers used to run thermal profiling with a large, a medium, or a small board.
Right.
So now I have the opportunity to teach them how to do profiling, which I learned early on working at Heller.
Right.
The biggest issue with the Kick product, it's built into the Heller, but it's teaching the customers how to use it.
To use it properly.
And they have so many different products that can be used depending on what the applications are. And most of the customers that I have, once you teach them how to use it, they really like the product and they start using it.
Right.
It's not difficult.
Yeah. Now, I mean, we're moving very much into a data-driven world. Customers are really looking for more data, and it's a lot more, and it's much more software-driven, of course. How does that work? How does that fit in with you as a manufacturer's rep?
Right.
Having to understand the software side of it,
Sure.
and systems and data, and being able to advise customers on it.
So I'm working with a number of the accounts that I have now. I work with Identco for labeling, and we're working with these customers to provide full tracking through their system. It's a very difficult task for some of them because they're not used to it. They may be used to just placing labels or serial numbers on a board.
Yeah.
But now we've tried to automate that and tried to help them automate it. So I work as an advocate for some of my customers to get them through that process. ISO's created this issue where people have to follow rules, and they follow the rules, and they keep asking the questions. Same thing with board cleaning. You can clean a board matter of different ways, different options, but now you've got to clean the board and be able to prove that it's clean.
Prove that it's clean. You got to have the data. You got to have the reinforceable data to prove.
Correct. So I'm working with Magnalytics now.
Okay.
Magnalytics can provide that ability to test their boards, test their process, and print out a report so that they can supply that to their customers.
Yeah, it's a lovely system. Yeah,
Yep.
Yeah, great. I believe you're also expanding your footprint because traditionally you've been up in the northwest, sort of. Is it Long Island area or which
I typically cover southeastern New York State, New Jersey, eastern PA. I have had opportunities to travel out to the West Coast early on in my career, so I've got a lot of friends out there, and I've started working with some of those accounts now.
Right.
MW Associates, who I use for my marketing, is providing me with a lot of their customers and made some introductions for me, and now I'm supplying service and support to those customers. And I'm enjoying it because it's a different group of customers than the East Coast.
Right. It must be stretching you though. Because you're working on two different coasts. So how do you deal with that?
So I travel out there now once every 2 months. I deal with the customers through email and over the phone. But I've been able so far to help them out and get them what they need.
Yeah.
So.
Great. Well, I'm sure you're racking up the air miles.
Yeah.
So, but it sounds like an exciting development. So great to see that things are progressing well for you, Don.
You too. And thank you very much for the opportunity again this year. So.
Yeah.
Yep.
Thanks for coming in and telling
I'll
us
see you at
about it.
Prototronica.
We'll see you at Prototronica next month.
Imagine the competitive advantages of producing high mix and high volume PCB assembly on a single SMT line, running non-stop even during changeovers. It's available now from the only maker in the world providing mixed production SMT line solutions complete with full dual printing, SPI, pick and place, reflow, AOI and board handling machinery for different product dual lane processing in the smallest footprint possible. Make more PCB assemblies with less time, less space, less investment.
So my next guest today is Chuck Bauer from Techlead Corporation. Nice to see you, Chuck. Thank you for coming in.
Thank you, Trevor.
Yeah.
Good to see you as well.
Yeah, so I want to talk to you a little bit about this heterogeneous integration and some of the interconnection technologies, and dive down a little bit into the chiplets that are being used. What are some of the pros and cons of using chiplets?
Well, I think it's clear that the chiplets provides flexibility and design opportunity. In particular, chiplets are really just kind of a downsizing of the modularization that we've been going through for the last 30 years, if you think about it.
Right.
And, the other thing is chiplets, everybody talks about chiplets like it's something new. They've been around since the 50s, 1950s.
Right.
Because we've been doing hybrids forever. And, we're now doing it with, instead of a ceramic substrate, it's a glass or silicon substrate. Instead of screen printing, it's now more of a thin film process to create the substrates and that sort of thing. So the challenges and the opportunities are really quite similar to what we've been dealing with for the last 50 years in the arena in general. But the biggest pro for chiplets is that flexibility and the ability to manipulate the final design
Right.
in mid-process. Okay.
Okay.
And you can be building a chiplet-based system, and if you update, you can update one chiplet, and you can drop it in.
And drop
if
it in,
do
and
it
you can
correctly.
keep and not have to do a complete redesign.
Exactly. Now, the disadvantages are, one, and I guess one more pro I would throw in there first is you also have the ability to distribute the thermal profile of the complete product
Yeah.
a little more efficiently in your design process.
Right.
The downside is that you're still introducing a little bit of delay into the circuit. Now, it's not much, okay, in today's world.
Right.
But as we continue to advance and increase
You
data
want to get that
requirements,
latency.
you're going to get you're going to run into latency issues eventually.
Right.
The other con is really two things. One, the lack of standardization, and a question about whether or not standardization is even the right path.
Right. Well, that was going to be my next question. Really, was
Okay.
your view on
Sure.
standardization?
Because, standardization certainly facilitates the communication process when you have multiple chiplet providers.
Yes.
But on the other hand, in today's stage of development in the chiplet industry, each product really is still a fully custom product anyway. So it's not clear that standardization is going to really kickstart the industry or kickstart the product flow.
Well, maybe the communication between the chiplets could be standardized.
Agreed. Yeah. From an architectural standpoint,
Yeah.
there are some standard partitioning policies that are useful.
Right.
But in terms of standardizing the substrate or the footprint of the chiplets, that's I'm not sure that that's going to really do anything for the industry right away.
Right. Right.
Because right now we're looking at large monolithic companies that are doing it, and they're buying pieces from other companies, but they're doing sufficient volumes that they do it based on how they're going to make their product perform the best.
Right. Right.
And that's even what's driving architecture
Right.
now too.
Right.
So the question is there when is it going to get to the point where the little guys are able to play the game? And when the little guys can play the game, they're going to need standardization because they're not going to be able to influence the suppliers
Very true.
of the substrates, let alone the chiplets. Guys that are providing the chiplets, in particular, what we traditionally have called glue logic and the memory devices, those are already fairly standardized.
Right.
So there's not a big drive there. So I would say that that's one of the cons. The other con to chiplets, I think, comes from the substrate itself, in that we don't really have a well-developed infrastructure for either silicon or glass as a substrate for chiplets.
Right.
And because of that, it's hard. It's a chicken and egg situation for the industry.
Yeah.
So
You get different
right
grades
now,
of silicon and things like that.
exactly. And really, the only people who can do it are the big monolithic companies that can afford to drive that development.
But I mean, standardizing a level playing field for everybody.
Eventually, yes.
Yeah.
Right. But if you're a big monolithic company and you're using chiplets to gain a market advantage, how much are you going to really support standardization from a competitive perspective?
Well, that's true. I mean, but it gets driven further up the tree by their customers.
True.
Requesting in the bill of goods that they send out that the packages are manufactured to the standard.
Correct.
Yeah.
I think that the other driver for standardization and the other risk for the chiplet industry is who is going to actually be the assembler.
Right.
Okay. Is it the OEM?
Right.
Or is that going to be transitioning to the contract manufacturers as well? And
There's evidence to support both, actually.
Exactly.
Yeah.
Right.
Yeah. So it's an interesting one. There's an increasing number of contract manufacturers putting clean rooms into their facilities.
Right.
But there's also new OSATs jumping up here and there. So I think it's going to be a mix.
And you can see the trade-offs there as well, because if you're an OEM who's designing the product and controlling it, and if you're a Samsung or an Intel,
right,
you can design almost all of the chiplets that are going into your package.
Yeah.
If you're more a moderate size, you might be big enough that chiplets provide advantage and competitive edge for you, but you don't necessarily have the ability to produce all of your components to go into that chiplet package.
Right.
I think another interesting paradigm is how much is going to end up being built into the substrates. Because in the printed circuit board industry, we can't really do that very well.
Right.
But on silicon and glass, with thin film technology, you have a lot more capability in terms of resistors, conductors, and even capacitors for minor implementation.
Well, I think that's true, and I think that falls into the area where everything's going in the Z direction.
Right.
Yep. So I think that's certainly a technology to be developed, for the future.
I agree.
Yeah.
So I think that chiplets are clearly a force in the industry today. There's no argument that they're not going to happen.
Right.
They've already happened.
Yeah.
And they're starting to proliferate. And like most products, they're going to be driven by volume applications.
Very true.
I mean, we made that transition in the late 80s when all of a sudden Mill Aerospace didn't drive technology anymore. All of a sudden it was the consumer driving technology.
Consumer-driven cell phones and that sort of stuff.
Exactly.
Yeah.
And so that's the same thing that's going to drive the chiplet revolution as well. I think that there's going to be a lot of focus on the very high end initially because of the lack of infrastructure for substrates.
Yes.
You really don't have. You only have a handful of people who can do it right now, and so it's going to be relegated to the high end. And what's going to drive it is a lot of what's going on in the arena of machine learning. I think that's going to be a key player for the chiplet.
There is. There's also some new technologies coming out. I mean, there's one, for example, coming out from Terra Circuits where they're placing chiplets into packages without soldering, without any kind of interconnection, and it's a direct contact,
right?
And overmolded.
Yep.
And I believe that's about less than a year away from going into mass production.
Right.
So.
And, we actually, not meaning to put in a plug for the Pan Pacific, but actually Suganuma Sensei from Osaka University is going to be one of our keynotes at the Pan Pacific. And he's been working on the direct bonding assembly technology for almost 30 years.
Really?
Yeah. So he knows the technology inside out. So you're absolutely right. That kind of technology is one of the things that's going to be a real enabler. And I think at that point, that's where standardization will become important because it's harder to manage that kind of a process with that. But again, it's a new technology, and new technology always brings cost and risk. And so, he's been working on it for 30 years. The industry has been looking at it seriously for maybe 5 years.
Yep.
So we're probably still 5 to 7 years away from true mass production. We'll have products.
No, things are happening faster. Innovation happens faster.
Absolutely.
You've seen it throughout our lifetimes.
Absolutely. You look at. I always used to talk about what my grandmother saw in the 100 years that she was alive.
Right.
And I'm sitting here. I've been around for 73 years now, and I'm going, wow, I've seen just as much as she did.
That's true. So. Fascinating topic, Chuck. We could talk about it all day, I know,
Absolutely.
But I know you've got a plane to catch, so I want to thank you for making the time to come in.
Thank you, Trevor, and best of luck to you.